Good morning, my angels. Good to see you here. Those of you that are here, today is Take Your Kids to Work Day, which means I'm missing a few humans. Those of you that are at home, we're going to have to mark this yourself. Our test is a week from today, so it's Wednesday. I think it ends up being November 8th, I think, because today is the 1st, and if you add 7 to 1, you get 8. See how it rolls? Okay. We're going to mark this. If you are away today, or if you haven't done it yet, you can do it on your own and mark it yourself. I'll put both a PDF answer key as well as a video answer key online. Today, you're also going to be getting some more practice drawing board diagrams, because that seems to be what kids have struggled with the most in the past. And then it's going to be get the other stuff done as well. So, since I only have, 3 humans here, that's an ideal class size. Let's go like this. This is answers now. And we have to put my favorite student's name on here. Good old Anne. She gets everything right. I got my periodic table, my pink periodic table out because I know what I'm doing. So, circle the best answer. Marco, I'm going to be picking on you as well. Approximately how many elements have been discovered? You should be able to do this without actually having to think too hard. Is the answer 3? Or do we have more than 3 elements? So cross that out, all of you, right now, if you haven't already. Is the answer 35? No? Is the answer 300? No. How many are there on your periodic table? About 120. Every so often in a particle accelerator, we're able to temporarily, for a trillionth of a second, create one more. There is a possibility, if we can build up enough energy to create it, that I think there's a theoretical possibility that element 122 or 123 might actually be stable-ish, maybe. It's a really complicated overlapping electron shells situation, and so we're not sure. I'm pretty sure I read that somewhere. I'd have to look that up again. Name 2 metals that are not silver-colored. This is just, I'm going to say, kind of common knowledge-ish. A, B, C, or D. First of all, is sulfur a metal? Cross out A. Cross out D. Is chlorine a metal? Cross out C. Even if you don't know that copper is copper-colored. Yes, that's where it comes from. And gold is, what color is gold? Gold. Wow. Even if you didn't know that, you need to start learning that you can cross out wrong answers and figure out the right answer. Which of the following is a metalloid? Now, the metalloids in your textbook are kind of a little colored one in your textbook. They're right along this staircase. So, is sodium a metalloid? No, it's way over there on the left. Is sulfur a metalloid? Nope, it's further to the right. Is strontium a metalloid? I skipped silicon because that's one I'm not sure of. It is silicon. Silicon can behave like a metal and it can behave like a non-metal. That's why we use it in what we call semiconductors. We can make it conduct sometimes and not sometimes. What's a period in the periodic table? A vertical column? A horizontal row? A family of elements with similar properties? A group of elements which have all the same number of valence electrons? What do we call the vertical columns? We don't call those period. We call those something that begins with the letter F. Families. Is it a horizontal row? Quentin is nodding. B. Also, the period number tells you how many electron shells there are. If you really want to get fancy, it tells you how many electron energy levels are being used up. And if you take quantum physics, you'll stop talking about shells. You'll start talking about energy levels. And that's where it gets weird. I'll go on a rant later. What do the noble gases He and Kr, helium and krypton, have in common? Do they have the same number of electrons? No. Helium has 2 electrons. Krypton has 36 electrons. I got that from the periodic table from their atomic number. Do they have the same number of valence electrons? No. Helium has 2. Krypton has, I think, 18. What's we mentioned? What you looking for? Okay. D, both gases will make a balloon tend to float. I showed you a video of the noble gases, and do you remember as we went further up, the balloons, instead of floating, they dropped almost like a rock. What's the correct answer? mentioned. I'll give you that one correct now if you figured it out partway through. And the reason they're so stable is their valence shells are full, which means they neither wish to gain or lose electrons. And so getting them to react is nearly impossible. Sort of like you folks first thing in the morning. Getting you to react is nearly okay. How is the periodic table arranged? By atomic mass? No. You know what? It's by atomic number. I read down to D. It goes up by atomic number. Then the reason the columns exist is chemical properties. And it turns out because they have similar chemical properties, it also ends up being ion charge. C is sort of right, but really, first it's by atomic number first. And what does the atomic number tell you? Two main things. The number of what? Protons, which is what defines an atom. And if the atom is neutral, the number of electrons. No, doesn't. The atomic number doesn't tell you the number of neutrons. You have to do some math to figure out the number of neutrons, right? Mass minus number. Next page. Nitrogen atom is formed an ion. Which of the following statements is correct? First of all, I looked at nitrogen. I saw it was 3 minus, so I crossed out B and I crossed out D. And if you didn't do that, you're not a good test writer. Because I've now turned it from 4 into 2. I've turned it into a true-false guessing question, something else. Does it lose 3 electrons or gain 3 electrons? And that you're going to have to figure out by looking here where it is at the periodic table. It wants to get a full valence shell. I think it wants to move this way. That's the closest. Ha! It is gain. Which phrase is correct for a Bohr model of a metal ion? So metals. It's talking about... oh, you know what? I crossed out C. If it's an ion, it can't have an equal number of protons and electrons, because an ion means it has a charge. You okay with that? Equal number of neutrons and protons? No, I crossed out D. That's nothing to do with ions. That has to do with a mass minus atomic number. And you notice at the beginning, often the neutrons and protons match, but as you go further on, no. So, for a metal ion, does it have more protons than electrons or more electrons? Really, it's asking this. Do metals gain electrons or lose electrons? Lose, so you'll have more protons. Okay. And again, the fact that they are so eager, so happy, so easy to lose electrons, it's why metals conduct electricity. Electricity, the root word of which is electron. It's passing electrons through wires. Which best describes the alkaline? Okay, alkaline is the second family. It's magnetic. I don't know if it is. I don't know this. Family of metals used to make coins. Nickel is used, but that's not in that family. Copper is used. Actually, zinc is used an awful lot now in pennies. So I don't think so. Oh, you know what? It's D, isn't it? 2 valence electrons. Okay? So even though I honestly don't know the answer to A, B, or C, I don't know which metals are magnetic. Most are. Not all. Family of metals used to make coins. I don't know. D is clearly the correct answer. A scandium element, I went and found it, element 21, has formed an ion. Which is correct? So scandium has a charge of 3+. I crossed out C, I crossed out A. Quentin? The only way you can have a charge of 3+ is if you lose 3 electrons. Good. There's probably going to be some kind of little matching section on your test. You figured out that you cross stuff out on this as well because you can then use a process of elimination. Now, sometimes nasty matchings will give you extras, or they'll say some can be used more than once. I read the instructions. It says each descriptor can be used only once, so once I use it, cross it out. Atomic mass, that's F. Noble gases, the family of chemically unreactive gases, that's G. Atomic number, that's the number of protons in an atom, that's B. Bohr model, H. And I'm always careful. It's a model. It's not really what the electrons look like, but it explains a lot, and you'll find out next unit even more. We can use the Bohr model to predict how atoms will combine. Okay, metalloid. Oh, that's the properties of both metals and nonmetals. And I mean, that's kind of weird, but wait a minute. Are the metalloids kind of halfway between the metals and the nonmetals? Maybe it's not surprising that they have a little of both. Alkali metal. A. Which one didn't we use? C. Contain the element fluorine. I think those are called the fluorides. You've heard the term before, like in toothpaste and things. And E. Compares the inside of an atom to a raisin bun. That was Thompson's plum pudding. That was from last chapter. So, Fagubahadaha. Okay. FGBHDA. I don't know how you'd say it. Something like that. Turn the page. 4 marks, 4 things that are included in a periodic table in addition to the element's name. I had somebody ask me this question last class, and then their eyes lit up because they looked right here. Because they looked right here. Because they looked right, there we go. Ta-da. So what are the 4 things? Give me some. I gotta be fussy. It's the atomic number, because if you just say number, there's so many numbers. Oh, did you say atomic number? What else? Symbol? What else mentioned? What else?
Atomic mass.
Now those are right from there. What else can you figure out from the periodic table? Number of? Number of. I'd take those. Except now I need to move this over a little bit. Let's go like that. Let's go like that. What else? Actually, there's a lot more stuff that you don't realize yet, but there's way more information on there too. And you can get periodic tables, Marco, that have even more information. Like if you're a chemist, you'd have a periodic table, and each element would have even more things. They would probably go into the types of electron shells. There's what are called P shells and S shells. Connor, are you in Chem? Okay. I've only done Chem 11, and you don't look at the shells in Chem 11. You look at the different types of shells in Chem 12. There's actually different types of shells that have different energy level arrangements and things like that. All right. And we did fix the typo that it's, I think, mentioned. You spotted that I had written Na2 plus instead of Na plus. We're going to draw a simple Bohr diagram of a sodium atom. I'm going to have to freehand this. It's going to suck. I can't draw. No, I'm just warning you. So oh, wait a minute, Mr. Dewick. Mr. Dewick, you clever person, you. Draw. Ha! Look at that. There's my nucleus. I'm going to write the fact that this is a sodium atom. Nah. How many protons? Is it 11 protons? Is it 10? 23 take away 11. 12? Is it 12 neutrons? Yep. Okay. Then there is going to be one shell, the innermost shell. How many electrons will it have? Then there's going to be nope, don't do that. Another shell. Move it over a little bit, Mr. Dewick. How many electrons in the next shell? No, 8. 1, 2, 3, 4. Pair. And just to show you how bad this would have been if I'd freehanded. Don't! Don't! How many electrons in the final valence shell? Put it anywhere. Okay. How would I mark that? Now, for 3 marks, I probably go 3 marks each. Typically what I do, I give you 1 mark for the nucleus, 1 mark for the right number of shells, and then 1 mark for the correct electron arrangement. So every mistake you make, you lose that mark. Sorry. Okay. B, an ion. You ready? You like this. Copy. Paste. How do I turn this into an ion? How does sodium form an ion? Does it want to fill its outer shell? Isn't that cool? Now, how do I then show that I did this deliberately? Square brackets. Plus. Okay? If you miss the square brackets, that would cost you a mark. Okay? And I'm going to say, Manchin, I'm glad you did it here, because you're going to now your job is get angry at yourself for making that sloppy mistake so that you won't ever do it on the test again, right? That's a sloppy mistake. You're going, I can't believe I forgot that. Those are the ones I want you to try and get rid of. I don't mind it if you get something wrong because you honestly didn't know it, but if you get something wrong because you're sloppy or didn't notice there was a back page, those are things we want to avoid, right? What's the valence electron, Manchin? Electron, yeah. Okay. How are valence electrons related to chemical families? This is a bit of a vague question. Good. I'll make it a bit longer. Same number of valence electrons. I'd take your answer, Quentin, totally, but I'll be a little... Same number is really what you're saying, right? Okay. That's why the columns have to be where they are. Do nonmetals tend to gain or lose as they form ions? Nonmetals? Gain? See how lazy I am? I just circled the word gain. In the spaces provided, draw 2 Bohr model diagrams for the 2 named elements. Oxygen ion. This one I will freehand just so you can see how bad it is. Important message there, Marco? Yeah, I saw you. Oxygen. How many protons? 8. How many neutrons? Also 8. Then we have the electron shells. Here's the first one. 2. Here's the second one. Now normally it has 1, 2, 3, 4, and then pair 5, pair 6. Is this an atom or an ion? Ion. So it's going to fill its outer shell. I'll just change colors so you can see the 2 that I added. Where would those 2 electrons have come from? Probably a metal that wanted to get rid of its electrons. And that's why oxygen will bind so nicely with metal. By the way, that right there, it's why metal rusts. Rust is oxygen combined with the metal. That's an oxide. How do I show it's an ion on purpose? Mentioned? Okay. 2 marks each. I'd probably go half mark for the number for the correct nucleus, half mark for the number of electrons being correct, the shells being correct, half mark for the square brackets, and a half mark for the ion charge. Something like that. Argon, ooh. Full shell. 3 shells. Okay, here we go. Nucleus in the middle. 18 protons. How many neutrons? Really? 4? Oh, yeah, it is. Okay. Then I'm going to have electron shells. I'm going to have a 2. I'm going to have an 8. try and be a little neater than me, but this is just to let you know I won't take marks off for not neatness. I have trouble drawing. And there's going to be another 8. 1, 2, 3, 4, 5, 6, 7, 8. By the way, what if this said draw krypton? I would never ask you, but how many would there be in the next shell? You lose a half mark. Here's the problem, Mansion. I hadn't explained to you why they pair, and it turns out they pair a little more complicatedly than I've explained it. You're going to notice in today's assignment there's an additional little strange pattern that occurs, and it's a quantum physics thing, and to be perfectly frank, I don't understand it. I haven't dove that far down into why they pair. I just know it's quantum physics and energy levels. I think it's related to electron spin, stuff like that. Nearly done. As the rows increase, what happens to the number of electron shells? I'll give you a hint. Go up by the number of electron shells, not the number of electrons in the shells, just the number of shells. Every time you drop down a row, you go up by how many shells? Okay. Now, in the shells, Quentin, absolutely 2, 8, 8, 18, and then it gets yucky. Yeah. How many electrons are there in the valence shell of a sulfur atom? How do you figure that out so fast? Count. Yeah, but count, right? 1, 2, 3, 4, 5, 6. There's other shortcuts you might spot, but when in doubt, the counting thing will get you there. And typically on a test, I don't use the shortcuts. I'll use the one that I know is going to get me the right answer. 6. How many electron shells in a sulfur atom? 3. There's absolutely going to be a question like number 24 on your test. Here, though, unlike the quiz you did last class, we're talking about atom or ion, question mark, yes or no, is it, or A for atom, I for ion, whatever you want. So the element is magnesium, that's atomic number 12. It has an, you know what, change colors, Mr. Dewick, so it stands out. It has an ion charge of 0, so that means it's an atom. How many protons? 12. How many electrons? 12. Okay. Marco, my friend, what's the atomic number of the next one? Just read it to me. Oh, I thought you were working along with me. I'm sorry. My bad. I take that back. I thought you were following along. Mansion. Atomic number? Which element? Is it oxygen? Sorry, what element? Oh. Huh? See here. What element? Oxygen? Oh. Oh. Nothing? Wow, nothing. Does this have an ion charge? So it's an ion. How many protons? 8. That never changes. How many electrons? Here's the interesting part. How many? 10. It's not because, for some stupid reason. It's because Benjamin Franklin should have called electrons positive. He didn't. So since electrons are negative, you're always doing a minus minus. If you minus 2, that's like plusing 2. Okay. 19 protons means it's got an atomic number of 19. Element number 19. Okay. Okay. Nothing. Okay. Has it got an ion charge? Yes, so it's an ion. So how many electrons will potassium have? Yes, it wants to lose. I don't know. This next line is a little trickier. So we have 18 electrons and an ion charge of 2 minus. So how many protons must we have? 16. What's the atomic number then? 16. What's the element then? 16. Sulfur. And it's an ion. 4 electrons and an ion charge of 0. That means it's an atom. So 4 electrons means 4 protons, means element number 4, means beryllium. And it's an atom. Okay? Is that all right? Aced it? I'm not actually going to be collecting this quiz for a score. This is a study guide for you, though. You've just seen a bunch of the questions that are on the test. If you didn't finish, I strongly encourage you, though, work through this. I'll post the answer key online. What's my website? pitmath.com. So there's a PDF as well as a YouTube video. Click on Science 9 and do a bit of navigation. If you're not sure, I can walk you through it. Okay? What are we working on today? So you can finish the stuff off. A lot of you still haven't finished off the Bohr model, atoms and ions. A few of you have. That's this handy handout here. And we're going to practice a few more Bohr atoms. So you have a Bohr diagram periodic table. You don't need to worry about fitting in the protons and neutrons inside the nucleus because I made this really small to fit it on one page. But what you can do is write the protons, neutrons, and electrons right there. Write the atom name right there. Fill in the atomic mass, and then draw them. I did the shells for you. You can just fill in the appropriate electron dots. Actually, it'll go pretty quick. Okay. The answers are on the back and mentioned if you look. Don't copy and cheat. But this is where you asked me about when do they pair. And this is where I haven't explained everything to you. You may notice actually the first two pair, and then it goes 1, 1, 1, pair, pair, pair. I'm not going to get into that much detail. I'm going to say for Science 9, do the first 4 like the compass points, and then after that, pair, 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 pair. Is that okay? You get that done, and you finish stuff from last day, and you're good to go.